Hey guys, back again. Sorry about that. So, I did actually have someone knocking on my door. So it's probably a good time just to pause, anyways, because it did actually take a little while for everything to build. So I had to push it a few times. Apparently, it's missing some points for VAV damper, air damper. Air damper position, air damper or airflow set points, and reheat valves. So some of that I had to constantly ask it, where's it at? Where's the link? So I had to push it. And it seemed to be like, it looks like it thought for 18 minutes to generate all this. So I have no idea what the results are going to look like here, but see if we get something useful out of this. Okay, and it did actually give us looks like it generated in HTML, which I have no idea what it's going to look at. I just asked it to wow me. And then what the Python programming language has inside of it, there's a test server for web app testing purposes where you can serve HTML files through something built into the Python language. And then when you do that, that's when you can do cool things with for analytics purposes. You can serve JavaScript files and probably do something a little more fancy than you could without it. Okay, so follow the Open-Meteo cookbook. Workflow, central validation, false on HU rules. One important limitation is the upload export has rich zone temp state, but I did not find any individual airflow. VAV airflow, reheat valve command, or VAV discharge air temp history. So VAV, not enough we can do with VAV boxes. Okay, so let's see what we have here. So this is my, I'm just going to get into, one second. I'm just going to get into, view this. This looks like my extract view. See what ChatGPT made for us. Okay, so it looked like it made a HTML file. I'm just going to open up PowerShell here. I have Python installed on this computer, so it shouldn't be a problem. And then if just ping me if anyone wants any help with that. So like I said, I just can run it just like this, and then I should open up the. Okay, so it's serving all the HTML file on port 8000. So I should be able to go to localhost 8000. Okay, so here we go. This looks like our HTML file. Okay, so it made this little dashboard. So kind of cool. I thought this would be neat because I was thinking about doing a Word document, or if AI can generate HTML code, why wouldn't we want to do this? Because it can make something more cool. Another thing we should have done is, even put the warnings in here. Actually, this makes me think of, like, we could have asked for zone recovery information. So if there was like a zone that doesn't recover very well in a degree per minute fashion, whether it's pulling it down or in the wintertime you'd be warming it up, that you could fault on poor performance, poor mechanical performance. Okay, so it did compute a bunch of things. And it does not look like it's... Okay, so looks like we have some issues here. I'll feed that back into ChatGPT. Please test before letting me download. So it looks like we have some bugs in the HTML file. Okay, hopefully this is worth the hour of my life on a Sunday. Well, nothing else is really going on. Okay, so ChatGPT said yes. It took 18 minutes for it to put this together. You're right, that should have been tested. I'm going to fix the RCx report. Gosh, what else should we do? So we just thought of that. Well, maybe let's just see what it gets, what it'll deliver us here. But we could ask it to do, I'll have to think about more things to ask besides asking for more granular data and more data for VAVs. I'll have to think about more what rules we can all run. I'm also going to say, please include on the HTML file which rules were all set up. There's also no data model here either. So like, this also is something that would not scale. But I think like if you were scaling things, like you would want to use a data model in like Brick or Haystack, but AI, like I didn't have to tell it, I didn't tell AI anything about the names of the points or the, not really much about the feeds relationships between, it's kind of like a somewhat of a simpler system though, because there's the 2 air handling units. So there's only 2 ways that air could be getting delivered to the zone, and then 2 chillers, which are, 1 common chilled water system. So there's not like it's not a very complex building where you need advanced feeds relationships. I think like what would be useful in a data model would be for algorithms purposes. So like, and fault detection rules. So like if we had, like AI is just hard coding right now what it needs, and it can make the data models really easily anyways. But like if it's just like a debate if we should have a data model here or not. Because like, does the AI need an advanced RDF model for Brick and Haystack? I don't think so. But yeah, I don't know. It's a hard one. I think like if you were at scale, if you had some, like if I'm just the standalone analyst here, working in my little office, and just some random CSV files here, there, everywhere, random CSV files, I don't think I would make a data model, is this kind of fashion of doing things. But if I had like a massive data lake, really big server, and I'm constantly appending new data, it's still a live system, then I would probably use one. Okay, so it's fixing. It's actually taking a little bit longer than I thought it would. Okay, so I'm gonna actually kill this, because this will be dead code now. So in my experience with this kind of stuff, ChatGPT is just going to send a completely new zip file of stuff, a version 2. Kind of curious, like if what you guys think. So like, as you know, if like a standalone analyst, this is saving me a lot of time, I guess. Like if it takes like an hour to play around with this, I bet it would take me, if I was just doing this all manually, rewind time before AI, this should probably 2 days, 2 solid days, I bet. So that's like 16 hours worth of work. And then I am just kind of playing around with this like an hour over a weekend. So that's already like, 10 times, probably, 10x at least faster than I can do it, more than that. So that's just my thoughts on this. And this is actually taking a little bit longer than I was hoping to. So if this is actually something worth the time, because I don't even know this yet, if this is, I'll try and post this just as an example of like a prompt for, maybe I should do that right now. So like I'm just going to copy this prompt. ChatGPT is still chugging away. And then if there's any other analysts that want to, so GitHub has this GitHub discussions. So this is something where you can write up a discussion. So this is just ideas. So it's kind of like just like a message board on GitHub. So this is, I'm going to say, ChatGPT prompt for offline CSV files to, let's say, to make reports in HTML. Okay, so I'm just going to paste it right in. Actually, hold up, that didn't format very well. So like, maybe I'll do a quote. Still didn't format very well. Text. See how that formatted. That's a little better. That gives a little copy thing. And then maybe this is something that I can improve and I iterate and then just keep an ongoing dialogue here on GitHub. And then the next person can comment on it, and you can, I can comment on an improved version, if this science experiment is even worth the time. Okay, so here we go. So I assume this is the bug fixed. Okay, so I'm just going to copy this Python run command, going to unzip you. Open up PowerShell again with Python installed. Run the Python web app. Then I should be able to just go, or this should be the same thing. Oh boy, okay, so lots of faults. BAS versus Open-Meteo, confirm faults. Scaffold. Go developer console. Okay, so this is the rules that were set up, computed. Maybe we could look at these a little closer in the future. I'm kind of out of time for today. Well, it's set up a lot of fault detection rules. Ooh, okay, so we have here, so we have some box plots. I didn't even ask for this. Zone performance distribution percent of occupied time samples within 72 degrees plus or minus 2 degrees. Okay, so AHU1 systems, AHU2. So this is a percentage of time. Within 72 plus or minus. This is the quantile. Okay, so end of heating season, the 20 worst performing zones by RCx performance score. So VAV 8. A couple of VAV boxes here. Well, looks like we have some deeper dives into mechanical systems. Mechanical cooling season worst ranking zones. Looks like this VAV 7 is continuously flagged for not a very good zone. Does not maintain set point very well. Comfort. Worst rank VAV zones. Oh, okay. So this is cool. So Open-Meteo temperature sensor versus the local building outside air temperature sensors. So it is actually doing something. So at least like I can tell through here that the web weather and the local building automation sensors, they're right. They're the correct sensors. So like we should be able to do some, oh yeah, this is Plotly. So this is cool. So we can do some deeper dives. And then a cool thing about Plotly too is you can download plots. So, okay, so like my mind is going to, we need better analytics on which one of these sensors is more, closer matches the web weather. So Open-Meteo web weather is blue, and these guys are the local sensors. It's interesting that air handling unit 1 and 2 have separate sensors. Usually in buildings, they share outside air temp sensors. So BAS outside air minus distributions. Oh, okay. So here we go. This is, for some reason, it stuck the boiler outside air temperature lockout. So that is just the set points to enable the boiler. That's why it has this constant let's see if I go back home. This purple line, that's the set point to enable the boiler system, which it looks like it changed at the end of perhaps the start of mechanical cooling season. They dropped that down. So the AI got confused. That's a set point. It's not outside air temp sensor. I'm just thinking some of these analytics need to be revised. Okay, so I am out of time, but I have to think about this like a little bit more. And there is just a ton of information here. So computed air handling unit faults by season. Mix air temperature below outside and return air temp. Free cooling. Okay, so cool. So let's see if we can turn this into some actionable insights. And okay, chiller plant trend. We have a chiller plant power. Looks like the power meter does not work. And we could even do like this is like the chilled water system when it runs. When it runs, the return temp back to the chiller is like 51 and 46. So 46-degree water is not that cold. Sometimes it's even colder. 6-degree delta. Just thinking. Looks like this power meter works. Okay, so I have a feeling like we're going to have to go back to ChatGPT and make, have it clean this up a little bit. There's just so much information here. It's almost enough that like it makes your head spin a little bit. So like what I wanted to do is break this HTML file down into tabs, multiple tabs. So what I was hoping to do is have a report for each season, and then once you break that down, you can do a report for each subsystem per season. There's just so much here. But we are calculating fault detection. So I think I'm going to stop it here, guys, and then let's go back tomorrow, and then we can create this into actionable insights, probably with pushing the AI. Maybe I can even demo this tomorrow with cursor agents to host this locally and clean it up with Fable in the latest AI model. So we'll get something cool. I can guarantee that. So thanks for watching. There might be a couple video series in making this all work. Talk to you later.